Okay, so Spectre. It's an attack that basically should never have happened. It's fixed in newer CPUs, and if a CPU has the attack vector, it cannot be fixed. Okay, so modern CPUs allow for programs to have private memory that other programs aren't allowed to read, right? Like you don't want to run a game and allow that program to read and write to system memory and potentially just infiltrate your system because it could be malware, right? So you protect the memory, but Spectre is an attack that basically lets any program read memory using a weird cache trick. Okay, so example. An attacker creates an array of size 256 cache blocks, makes sure it's not in the cache, right? So then it'll want to read, say, this value. This is just an arbitrary made-up value. I'm sorry about that. So it'll run this code, right, which will take the value out of that memory, right, stored in secret, and then it'll load this from the array of this value. And this code is executed in a way where the CPU's defenses for reading, for a program reading a memory address it's not allowed to, isn't fast enough to catch this. It does catch it eventually, and this value is undone before the program can read it directly, as it should. But this here, this will still run. And what this does is it puts, say, this value in the memory is 235. It'll put the block of index 235 in cache, where everything else is, right? So it reads block number 235, puts that in cache, but nothing else is in cache, right? So then the attacker can use this information where only this one of 256 is in cache to get that value out of it, right? And it can do that because a read from cache takes a thousandth of the time than a read from memory, right? And then a read from disk is about 1,000 times longer than a read from memory, and so on and so forth, right? Okay, because the CPU doesn't evict the block from cache, this works. Okay, so the CPU does realize eventually that it wasn't allowed to do that. It'll undo the memory changes, etc., as it should. But the program can see which one of the 256 blocks is in cache, right? So it does that. It'll go through so on and so forth, and it'll read each value, time how long it takes. And this one's like, oh, wow, 1,000th of the time. This must be it. And this is 235, index 235. So the value must be 235. Okay, that's it. Remarkably simple, right? And yes, it is remarkably simple for an attack that existed for decades in every CPU. So a high precision timer is used to do this. Otherwise, yeah, anything else. This process can go into unencumbered before the CPU realizes. Okay, cool.